Today we'll be discussing flame photometry and its application in a biochemistry lab. Flame photometry or atomic emission spectrometry is a branch of spectroscopy in which the species examined in the spectrometer are in the form of atoms. Flame photometer, an instrument used in inorganic chemical analysis to determine the concentration of certain metal ions, amongst them sodium, potassium, calcium, and lithium. Flame photometry is the branch of spectrometry in which species are examined in the spectrometer in the form of atoms, and the instrument used to determine the ions of certain metal such as sodium, lithium, etc. are known as flame photometer. So it works as on certain principles. Let's first talk about the principles and see them. The principles on which a flame photometer works are as follows. The transmissions of the atoms takes place to higher energy state whenever they're heated. So samples are first introduced into the flame as salt solution. The solvent is vaporized, leaving behind tiny particles of solid molecules, which further on heating are converted into gaseous molecules. These gaseous molecules are then decomposed into the gaseous atoms. Some of the gaseous metallic atoms absorb the heat energy from the flame and get excited. These atoms go to a higher energy state and then they return to a ground state by emitting radiations. We know the amount of radiations emitted and the wavelength of the emitted radiations. We can have then qualitative and quantitative analysis. Flame photometry is based on measurement of intensity of the light emitted when a metal is induced into flame. The wavelength of color tells us what the element is, and thus it is a qualitative test, and the intensity of the color tells us how much element is present. Thus it is a quantitative test. The basic principle upon which atomic spectroscopy is based on the fact that matter absorbs light at the same wavelength at which it emits light. When a metal salt solution is burned, the metal provides a colored flame, and each metal ion gives a different characteristic colored flame. Flame test therefore can be used to test for the absence or presence of a metal ion. The parts of a flame photometer. There is a source of flame such as a burner, a nebulizer and mixing chamber that helps to transport the homogeneous solution of the substance to the flame at a steady rate, an optical system and a photodetector. The source or flame provides flame and can be maintained in constant form and at constant temperature. Nebulizer and mixing chamber helps to transport the homogeneous solution of the substance into the flame at a steady rate. Optical system comprises of three parts: convex mirror, lens, and filter. The convex mirror helps to transmit light emitted from the atoms and focus the emissions to the lens. The convex lens helps to focus the light on a point called slit. The reflections from the mirror pass through the slit and reach the filters. This will isolate the wavelength to be measured from that of any other extraneous emissions. Hence, it acts as interference type color filters. What happens here is that these filters block all other wavelengths except for the atom that is being studied. Therefore, they allow us to measure the intensity of the specific wavelength associated with a certain atom. The photodetector, which is the last part of flame photometer, is a device that measures the emitted light's intensity, and the emitted radiation is then converted into an electrical signal with the help of a photodetector. This produces electrical signals that are directly proportional to the intensity of the light. Therefore, the intensity of the light can tell us about the concentration of the atom. Here we have a picture of the flame for spectrometer, and now we are going to move on to the mechanism. The nebulization is a process in which a dispenser turns a liquid into a fine mist called nebulizer, such as perfume. The solution of the substance upon which the nebulizer acts is to be analyzed is first aspirated into the burner, which is then dispersed into the flame as fine spray particles. A brief overview of the process. The solvent is first evaporated, leaving fine divided solid particles. These solid particles move towards the flame, where the gaseous atoms and ions are produced. The ions absorb the energy from the flame and get excited to high energy levels. When the atoms return to the ground state, radiation of the characteristic element is emitted. The intensity of light emitted is related to the concentration of the element. In the flame photometry employs a variety of fuels and air, oxygen or nitrous oxide as an oxidant. The temperature of the flame depends on oxidant fuel ratio. The intensity of the light emitted could be described by the Shih-Blomacken equation, where intensity is represented by I, C is the concentration of the element, K is the constant of proportionality, and N is to the power 1 at a linear part of the calibration curve. Then I is equals to Kc. That is, the intensity of light emitted is directly related to the concentration of the sample. The standard operating procedure is as follows. Both the standard stock solution and sample solution are prepared in deionized water. The flame of the photometer is calibrated by adjusting the air and gas. Then the flame is allowed to stabilize for about 5 minutes. Now the instrument is switched on and the lids of the filter chamber are opened to insert appropriate color filters. These filters allow us to study the specific ions that we need to specific ions or elements whose concentrations we need to find out. The reading of the galvanometer adjusted to 0 by spraying deionized water into the flame. The sensitivity is adjusted by spraying the most concentrated standard working solution into the flame. Now the full scale deflection of the galvanometer is recorded. By doing this, we calibrate the galvanometer to work between the concentrations of 0, that is this deionized water, and the most concentrated, and then we can find out the concentration between these two extremes. Again, deionized water is sprayed into the flame to attain constant readings of galvanometer. Then the galvanometer is readjusted to 0. Now each of the standard working solution is sprayed into the flame for 3 times and the readings of the galvanometer are recorded. This is very important because it allows us to make a graph upon which we can study different concentrations and find out the exact concentration of this sample that we are studying. After each spray, the apparatus must be thoroughly washed. The apparatus is washed so that there is no contamination between different standard solutions. Finally, sample solution is sprayed into the flame for 3 times and the readings of galvanometer are recorded. After each spray, the apparatus must be thoroughly washed. We repeat these readings so that we can find an average and make more accurate calibrations. Calculate the mean of the galvanometer reading. Plot the graph of concentration against the galvanometer reading to find out the concentration of element in the sample. Here we have a table which shows the elements, the emitted wavelengths, and the flame color. Please note that the emitted wavelengths are constant and the colors are determined by the wavelength. Applications of flame photometry. Photometer can be used to find both qualitative and quantitative results. Flame photometer with monochromatic emits radiations of characteristic wavelengths which help to detect the presence of particular metal in the sample. This helps to determine the availability of alkali and alkaline earth metals which are critical for soil cultivation. What we're doing is we're finding out the exact proportion of these metals in the earth so that we can find out the nutrients that are needed for plants. In agriculture, the fertilizer requirement of the soil is analyzed by flame test analysis of the soil. In clinical field, sodium and potassium ions in body fluids, muscles, and heart can be determined by diluting the blood serum and aspiration into the flame. Analysis of soft drinks, fruit juices, and alcohol can also be analyzed through flame photometry. Flame photometry has its advantages and disadvantages. The advantages include that it is simple, quantitative analytical test based on the flame analysis. It is inexpensive. The determination of elements such as alkali and alkaline earth metals is performed easily with most reliable and convenient methods. It is quite conservative, selective, and sensitive to even parts per million to parts per billion range. The disadvantages are that the concentration of the metal ion in the solution cannot be measured accurately. This is because the measurement of concentration depends upon a steady temperature of the flame. The temperature determines the number of atoms that are energized. Even small fluctuations in the temperature will change the concentration readings. A standard solution with known molarities is required for determining the concentration of the ions, which will correspond to the emission spectra, as you have already studied the calibration process. It is difficult to obtain the accurate results of ion with higher concentration. The information about the molecular structure of the compound present in the sample solution cannot be determined. The elements such as carbon, hydrogen, and halides cannot be detected due to its non-radiating nature. I want to elaborate upon the previous point that the molecular structure of the compound present in the sample solution cannot be determined because it is heated and the compound is broken down. Therefore, we can only study the individual atoms and not their bonding. Thank you. For any queries you can ask and let me know via your comments, and your response will be highly appreciated.